In the last section, we built this web crawler that prints data to the terminal as it crawls from page to page. This is fun, but typically you don't want to just print data out, you want to collect it, if not in a database, at least some sort of a well-formatted file. Fortunately, this is really easy to do with Scrapy, and in the process of doing it, we're going to be adding a little bit of, you might say, enterprise infrastructure to our crawler that's going to serve as well in building robust, scalable web crawlers in any situation. I've mentioned before, some of these mysterious Scrapy files off to the side that get magically created when we make a new project, and now we're going to be using one of them, items.py. This is where you define your items. Of course, an item is a type of content that you're scraping. In this case, we're scraping articles. So keep in mind these aren't Wikipedias or Wikipedia articles that we're scraping. Wikipedia is the source. It's one of our sources. You might imagine that we scrape articles from all over the place, many different websites, all with their own spiders, but they have this common article object, and we want to define the standardized fields for that. So we're going to change this sort of default Scrapy thing to article, create an article class, and it's going to have 3 fields. So we're going to have a title field. It's going to be scrapy.field, a URL field, it's also scrapy.field, and a last updated field. Alright, this may seem a little magical at first, but bear with me. I promise it's all going to come together. Back in our spider, wikipedia.py, we want to import this article class that we just defined. So from articlecrawler.items, import article. Great. We also need to modify our parsing function a bit. Instead of returning a dictionary of data, it's going to populate an article object. So let's just rearrange this. Article equals article. Article title is going to be equal to that. Article URL is going to be our response.url, and then article last updated is going to be that. Okay, now we're ready to use this article object to tell Scrapy what data we want written to file. The easiest way to do this is to pass a few extra command line arguments to our run spider command. Scrapy run spider wikipedia.py articles.csv and then the format tcsv. So you can also use -t-json or -t-xml. This says, write a CSV file and write it to articles.csv. There is one little caveat here though. We can't just run this. So in the past, we were using Ctrl+C to close our crawlers. Unfortunately, this can cause problems with how Scrapy batches data and writes to files if you just kill it prematurely before it finishes writing, and we can prevent this by giving it an explicit close spider page count with the -s flag and then allowing it to finish by itself, say with a page count of 10. So let's just say equals 10. And there you go. Let's check it out. Okay, it's crawling. There we go, and it stopped, and we should have an articles.csv file. If we cat it, great, there you go. We have 10 pages. So like I said before, you can also use this for the JSON and XML format, and it's a really great way to write data to files quickly. As is usually the case when it comes to programming, scraping provides the user with multiple ways to do things. So in the last section, we looked at an example where Scrapy would write CSV data to file. We also limited the number of pages it scraped with this command line option. But the command line options are hard to remember. Sometimes you just want to load some presets. So remember, in the last section we used the command closspider_pagecount equals 10. The -s here actually stands for settings. These are one-time settings that you can pass in via the command line, but if you want to make these applicable for every command, without having to write them each time, take a look at settings.py. We can write whatever we want in here. There's a bunch of great stuff. I would recommend reading through the comments and getting an idea of things you can control from this file. And it's pretty well documented by Scrapy. So let's try our close spider page count equals 10 right here in the settings file. And then what happens if we just get rid of this? It should still stop at just 10 pages. Alright, great. So it's still picked up on that without us having to explicitly say it. So check out this command here, the -o articles.csv-tcsv. Again, that means to write the output of this crawler to articles.csv in the format, CSV. There's another way you can write this with -s. So that would be feed_URI at say articles.csv, and then -s feed_format CSV. And that should do the same exact thing. And you might be guessing where this is going. If we know we can always dump the output of our crawlers into a CSV file or a JSON file, we can just put this into settings. So go back to our settings file, feed_URI articles.csv, and actually make sure we use the single quotes there, feed_format CSV. And let's actually mix this up a little bit, change it to JSON, just so we get something different. And we can get rid of all of this stuff entirely and just use the plain old scrapie run spider wikipedia.py. It should pick up on these settings. Great, and yeah, cat articles.json, check it out. Another neat feature of these scrapie settings is the ability to add settings to the spider itself, so this wikipedia.py spider. These configurations will also override for just that spider any configurations you have in the settings.py file. So we can test this out by adding to export data to, say, an XML file. So custom_settings, this is picked up by scrapie. It's going to be a Python dictionary. We want feed_URI, articles.xml to the other one we haven't done yet, and feed_format, XML. Okay, so for just this spider, it should pick up on the command, only scrape 10 articles in settings.py. But it'll override the JSON feed_URI and feed_format, and we should get an XML file. So there you have it, 3 ways to extract scrapie data to files in 3 different file formats. So far, we've seen a few of scrapie's moving parts and how they come together to crawl websites. You have the scrapie settings, which manages configure options for the entire project or for an individual spider. You have the spiders, which encompass all of the website's specific volatility and are custom built to turn a messy website into a consistent type of item. Then you have the scrapie items, the item objects themselves. Well, these items, at least in theory, don't require a website-specific knowledge to deal with anymore because all that was handled by the spider, their data isn't necessarily in the most clean or finalized state. We could write a bunch of cleaning code in the spider, of course. And by the time the data gets to the item object, let's say it's absolutely pristine, but then you might end up duplicating a lot of cleaning code in each spider, if you have multiple spiders from multiple websites. You also might want to do other centralized tasks, like data validation, checking for duplicate records, storing data, sorting data, storing the data in different ways, depending on maybe some value of some particular attribute of the item. And these centralized tasks are accomplished in the scrapie item pipeline, so each task in the pipeline is represented by a class in pipelines.py. So keep in mind, not all of the pipeline code needs to go here. You can certainly import classes and functions from elsewhere, but it's traditional to keep at least a reference to all of your pipeline code in this file. So let's read a couple of simple classes in pipeline.py1. To turn that last updated text that we saw in Wikipedia into an actual Python date object, another to discard the item, if any of the fields are missing or invalid. So in pipelines.py, remember we need to make a class for each pipeline function that we want to write. And the first one is going to be checkItemPipeline. This function process item we want to keep, the item object passed in is actually our article. So let's just rename that to remind ourselves. And what we want to do is we want to check each attribute in the article to make sure it exists. So if not article last updated, or not article URL, or not article title, let's raise a drop item exception. This drop item is from scrapie, so we can import that, and let's return to the article. The other thing we want to import is the date time. So from datetime, import datetime, and this is just the Python datetime object. So let's make another pipeline function called cleanDatePipeline. That's going to have same process item, self articles, spider. Alright. This is going to take the article and take the last updated. And then let's just replace that this page was last edited on text. Just as a reminder, this is what the text looks like from the Wikipedia page. So this page was last edited on, blah, blah, blah. Let's just go and replace that. This page was last edited on, replace that with an empty string, and then strip any white space around it. Article last updated, it's going to be equal to date time. This is the Python string to time function article last updated, and then we give it the date format. So that's going to be D capital B, Y at H, M, and then return the article. Okay. So now that we have these item pipelines written, how do we tell Scrapy that they should be called? For this we need to go back to the settings.py file. So in settings.py, you're going to see some commented configurations called item pipelines. Let's just uncomment this, and add our own pipelines in. So the first one is going to be check item pipeline. Let's just give this a value of 100. And then let's add the second one clean date pipeline, and give that a value of 200. The number value here on the right determines the order of the pipelines are called in. So lower numbers are performed first, higher numbers are performed last. Although the numbers can be in any range that you want, they're traditionally 0 through 1000. So alright, let's check it out. Scrapy run spider wikipedia.py. Although we won't be getting into databases in the series. If you do want to write your items to a database, the item pipelines are the preferred way to do that. If you just want to write your data to say J-file or something, use the built-in feed exports we looked at in the last section. Although I've talked a lot in previous videos about projects with multiple spiders, we've really only seen projects with a single spider so far, either the Wikipedia spider or the IATF scraper. So in this challenge, we're going to put 3 to the test and build a full Scrapy project with at least stubs of all the components working together. So you're going to want an item class, some pipeline process or processes, some settings that maybe export JSON or some other file format using the settings file. And the goal is to scrape some standard type of data from 3 different websites. So I'm going to scrape news articles from the Associated Press, CNN, and Yahoo News. If you don't like news articles, feel free to get a little creative with this. Products, profiles. A word of warning though, don't go too crazy. You want something common, present on a lot of different websites so you can pick a few sites that have all of the information you need readily accessible. So you can be a little bit creative with this, pick something you like, or you can be cool like me and just use news articles. CNN, Yahoo, and AP News are pretty good sites, just saying. But aim for a 3 scrapers, 3 sites, a single item class and an item pipeline, upbeat music. Like I said before, I decided to scrape news articles from Associated Press, CNN, and Yahoo News. To be honest, I got a little lucky with these sites. I did scope out a few different sources and picked ones that seemed moderately easy to scrape, but sometimes you really don't know what you're going to get until you actually build it. So everything went pretty smoothly, all things considered. I created a news article item, and that contains the title, description, date, author, full text, all that stuff. CNN was probably the most straightforward site to scrape. The only tricky thing I had to do was something that we already covered in Chapter 1, and that's use the metadata to get information. I was able to get really clean versions of the description and date published from the metadata in the header. The author's name was also there, but still required a little cleaning, which I did in the item pipeline. The text required a little bit of tricky finagling with Spath here. It's kind of a long selector, but I was able to extract it as a list of paragraphs using getAll. Associated Press was a little bit trickier. I struggled to find a clean source of the author and date and such, but then I saw that they had all this information as JSON text in the script tag on the page in the header. So this kind of thing is actually pretty common. It's used as a source for JavaScript code on the pag to access the data cleanly. So always keep an eye out for JSON blobs. They can be really handy when you're web scraping. So you can extract this blob of data as text, and then use Python's JSON.loads to turn it into a Python object. From there, you have all of the information in a beautiful, clean Python dictionary. Getting the body text data was a little bit harder here, but easier than CNN. So a little navigation with Spath, a little elbow grease, and just get them all. Yahoo was pretty similar to Associated Press. Again, I found most of the data in a JSON blob on the page. All that was left was the article text, navigate to it with Spath, get all the paragraphs. Now I want to take a look real quick at the rules that were used and the link extractor that I used. You have to do a little bit of detective work about what constitutes a news article or a product page or whatever it is when you're scraping versus what's a non-news article or maybe a main landing page. The regex took a little bit of trial and error, and I discovered some of the internal rules that these websites used. For instance, Associated Press starts with /article and always ends with a 32-character UUID. CNN always has the date, then they have 2 directories. Those directories can contain letters and dashes, didn't see any numbers, and always ends in index.html. So you really have to sort of use your powers of observation and see what's going on with the URLs when you're writing these. Alright, so on to the item pipeline. There wasn't too much I needed to do here. I mentioned that the author names from CNN needed to be cleaned up, so I did that. I transformed the date strings into actual Python date objects, cleaned up the article body text a little bit. From there, I can put this into a database, write it to a file, do some analysis, or maybe just catch up on the news. So our web crawlers have been making a lot of HTTP requests while they traverse the internet. These are the same HTTP requests that happen when you visit a website in your browser. And you can see all these requests pop up in your browser's developer tools as they're being made by the browser. And this can be a really handy starting point for scraping forms because all a website form is a sort of creative application of HTTP requests. So we can see this form over here and we can see this request in action. If you don't understand what this form is asking, or if you're a little confused, by the way, I recommend that you watch more Monty Python. But my name is Ryan, my quest is to seek the Grail of course, and my favorite color is blue, nope, green. My favorite color is green. Alright, let's do that. Let's see this form action.php down here, and you can see all those parameters I put in there, and the page uses those parameters to display some content there. And we can take advantage of this with ScrapeEye. So I happen to have a freshly created spider here in a project called Form. And we're going to use the spider to traverse a list of names and quests and scrape data from the page that shows up, that submitted form page. So we're going to do this by taking advantage of start URLs. Now usually we just put one URL in there and the caller takes care of the rest. But this time, we're going to be writing a function called generate start URLs that provides all of the URLs we want our scraper to traverse, given some set of form values. So def generate start URLs. Let's make some names. Alice, Bob, and Charles are always classics. Let's make some quests to seek the Grail, to learn Python, and to scrape the web. I mean, why else would you want to learn Python? Okay, and let's return these URLs that we made. So pythonscraping.com, LinkedIn, and that's going to be formaction.php where the form was submitted to. And then the get parameters. Name and quest and color, let's just hard code that, we'll make it blue. Name quest for name and names for quest and quest using the Python double list comprehension there. Alright, so start URLs, that's going to be generate start URLs. Then when we parse it, let's just return text, so this is going to be the text content of the page, which is at the X path. I looked it up so that you don't have to. Class is going to be wrapper. Text.get, okay, great. So save that, run it with ScrapeEye, run spider get form.py. Okay, perfect. And you should see, great, we've scraped all those different permutations of text from the page. But what about other types of forms? If you took out form2.php, you'll see it's very similar, but instead of making a get request, it actually makes a post request, so you don't see any of those get parameters there. No get parameters. But you do see this form data here. And we can actually use ScrapeEye to send form data as well. So I'm going to make a copy of this, and we're going to call it post form. So rename post form.py. And then instead of having this generate start URLs out top there, we're going to actually take advantage of a built-in scrapie function called start requests. Perfect. And so this is actually going to be an attribute of the class start requests, and scrapie knows about this. It knows that, just like start URLs, if you call a function start request, scrapie looks there and it looks for a list of form request objects to be returned. So a list of form request objects. We can import form requests. Sorry, from scrapie.http import form request. Okay, great. And this form request object takes a URL, so that's going to be formaction2.php. The other argument's going to take is form data. And that's just going to be a Python dictionary, so name is name, quest is quest, color, again, we'll just hard code that to be blue. And then a callback, that's going to be our self.parse function right there, and then get rid of that. For name in name, for quest in quest. That looks good. Oh, let's call this post form of course. Alright, and let's run this. Great, and then you see all the different permutations of that text from postform.py, so get request, post request. If you want to submit a form and scrape the content on the other side, there you go, you can do it with scrapie. One of the most important skills you can develop as a web scraper is your powers of investigation. So you can see the data right there, right on your screen. But also you need to know how it got there, right? Where it is, other sources of that data. You need to kind of understand how the website's working. So let's take an example that's kind of near and dear to my heart, Dunkin' Donuts. Now, something you never need to do where I live in the Boston area is search for a Dunkin' Donuts location. We typically just walk out of our front door and there's one right there, you know. But for the sake of example, let's check out the Dunkin' Donuts location finder, and I promise Dunkin' Donuts did not pay me for this, but you know, if they want to, I do accept free coffee. If I enter my zip code, 02155, I see 10 Dunkin' Donuts right there. And here's the one that's closest to my house for any fans seeking autographs. Let's see if this address, 850 Broadway, is located in the page's source. No, it is not. So what's going on here? Why do I see this on the page, but I don't see it in the source? Well, what's happening is that all of this content is being loaded dynamically. All of the page's source contains, all the HTML of the page contains is this search box form, and that form knows how to go out and make a request for some data at a totally different URL, and that data gets returned to some JavaScript code that sort of sneakily updates the DOM, or the contents of the page while I'm looking at it. And when I go to view the source, I don't see any of that content that got magically inserted, right? I don't see the current state of the page, all I see is this search box application that has the ability to go out and call JavaScript. So what to do? Well, we're looking in the wrong place. We don't want any of this HTML over here, even though that might look like where the content is. What we want is the URL that's being called by the page, which contains the actual location data. So let's try the search again, but while we're watching our network transactions very carefully. So, 02110, it's downtown Boston, and let's see if we see anything interesting. Oh, check that out. That looks like it might have some location data in it. Okay, so we can see the search results. Alright, great. So I'm not totally sure what all this stuff is. Suffolk County, kosher, Monday hours, weekday hours. Yeah, it looks like a lot of stuff that's not even displayed on the page there, which is pretty cool. And we can actually take a look at this URL and we can copy this and we can see if we can make the same request ourselves. Alright, great. Let's see what happens if we just start getting rid of stuff. So this callback thing there. Nice, that gives us better formatted of JSON. We get rid of that thing used by some JavaScript code up top. The key, do we need that? Yes, we do need the key, okay. So let's put that back in. This looks like our zip code, 0215, oops, that's not a real zip code. Let's put that back, 02155. That'll give me my zip code, max matches. What if we just change that to say 300? Oh, and that radius, maybe we change that to 250. Whoa, that's a lot of data we're getting back. Okay, a lot more than 10 results. So that's pretty cool. Just by doing a little bit of detective work and playing around, we go from this frustrating situation where we don't see the data on the page, it's just not there. What are we going to do? To basically having our own personal Dunkin' Donuts database. So keep an eye out for things like this. Whenever it seems like data is missing from the page and it's not where you'd expect it to be, look through the network transactions. I promise that data is coming from somewhere. It may just take a little bit of elbow grease or like a really strong cup of coffee.